everyone, welcome to PK Chemistry. In the earlier video, we have seen the conformational analysis, that is one part of stereochemistry or stereoisomerism, and the next part is configurational isomerism. We have seen conformational isomerism. What are conformational isomerism is? Those can be interconvertible. Two or more molecules can be interconvertible. Those are called as conformational isomerism. In that, we have seen the carbon-carbon rotation about the carbon-carbon single bond and amine inversion. Here the configurational isomers are, these cannot be interconvertible at room temperature. Two or more molecules having same molecular formula and structure, but these are isomers which do not interconvert rapidly at room temperature, and these can be separated. Again, the configurational isomers are classified into two classes: geometrical isomerism and optical isomerism. First, we shall see the geometrical isomerism. Then, what are geometrical isomerism? Geometrical isomerism are the isomers, and these are the isomers arises due to the restricted rotation about the double bond. It means when you have the double bonds or the ring, there is a restricted rotation about the double bond or the rings. So these are arises due to the restricted rotation about the double bond or the cyclic ring. Means when the two or more molecules having same groups in different positions around the double bonds, those are called as geometrical isomers. Means in the double bond, the position of the groups in the around the double bond will be different. Okay, when you have the double bond and the position of the double bond to that position of the molecules or the atoms to that double bond is different. Those are called as geometrical isomerism, and there are two classes in the geometrical isomers. One is cis, another is trans. When we have the same groups on the same side of the double bond, those are called as cis. When you have the same groups on the opposite side, those are called as trans. Okay, let's see the example. See, this is a double bond. Okay, there is a restricted rotation. We cannot rotate this double bond. In a single bond, we can rotate the single bond, as we have seen in the rotation about the carbon-carbon bond in the conformational analysis. But here there is a restricted rotation due to the double bond. We cannot rotate the carbon atoms which are involved in the double bond, and restricted rotation of the double bond. And these geometrical isomers are when the same two molecules are in different positions around the double bond. We have double bond, and these two groups are having the different positions around the double bond. These are called as geometrical isomerism. Cis is when these two in this example, you can see here this is a double bond, and this CH3 and hydrogen is attached to this carbon atom, and here the another carbon atom, alkene carbon atom, this is also having CH3 and hydrogen. But here you can see CH3 of this carbon and CH3 of this carbon are on the same side, of the double bond. This is a double bond on the same side of the bond. But when you see the second isomer, CH3 and CH3 are on the opposite side of the double bond. These type of isomers are called as geometrical isomerism or geometrical isomers. And when the two same groups on the same side of the double bond are called as cis. When the same groups on the opposite side are called as trans. Okay, this is about geometrical isomerism. Either it may be ring or the cyclic groups. And one condition is there. What is that condition? When the molecule or the alkene when the double bond having same groups to that carbon atom which is in the double bond, those will not show the geometrical isomerism. See here, the CH3, this carbon is having two hydrogens, means two same groups attached to this carbon atom, and here also two methyl groups attached to this carbon atom. So this type of molecule will not show the geometrical isomerism. The condition is the the groups which are attached to this carbon atom of the alkene must be different. Okay, here also same, the two methyl groups attached to the same carbon atom, so this will not show the GI, means these type of molecules don't show the geometrical isomerism. The groups should be different. Okay, then only the molecule shows the geometrical isomers. Okay, this is malic acid and fumaric acid. In the malic acid, see, this is a double bond. The definition is same groups on the same side. Here we have COOH group and here also we have COOH group. These two are on the same side of the double bond, then this is cis. When the same groups on the opposite side of the double bond, then these are called as trans. This is fumaric acid, trans is fumaric acid and cis is malic acid. And this can be observed, GI can be observed in the rings also. This is a ring, the CS3 groups are on the same side of the ring. This is a ring, same side of the ring, then this is cis. When the CS groups, same groups on the opposite side, then these are trans. Let's see the model. So this is a double bond, this is a double bond. These are carbon atoms, carbon-carbon double bond, and they are hydrogens. And these consider these two are methyl groups, the red methyl groups and white are hydrogens. See, this is a double bond. When these two are on the same side of the double bond, this is a double bond, and these methyl groups are on the same side of the double bond, these are called as cis. Okay, so model, these are carbon atoms. When these same methyl groups on the same side of the double bond, then this type of molecule is called as cis. See, this is trans. Here you can see that this is carbon atom of the double bond, this is hydrogen, this is methyl group. This methyl and this methyl are on the opposite side of the double bond. See, these two are on the opposite side of the double bond. This hydrogen and this hydrogen are on the opposite side of the double bond. Hence, this isomer is called as trans. And let's see whether this is trans or cis. Here you can see that this is a restricted rotation about the double bond, and here you can see that there are these two hydrogens. These two hydrogens are attached, same groups are attached to this same carbon atom which is involved in the alkene. Here also the two methyl groups are attached to the same carbon atom of the alkene, so that this cannot show the GI. These type of molecules cannot show the GI because same atoms or same groups are attached to the carbon of the alkene. Let's see the next example. This is also the ring. The two atoms which are attached to the double bond or the ring, there is no condition that those two should be same. This can be different. Here you can see, to this carbon atom, one atom is hydrogen, another one is chlorine. Here to this carbon atom, one is hydrogen, another one is bromine. When these two same atoms are on the same side, these two hydrogens are on the same side, hence it is cis. Or the higher priority groups, chlorine and bromine are the higher priority groups. And when these hydrogens, same groups on the opposite side, this hydrogen attached to this carbon is on the one above, and this hydrogen attached to this carbon atom is below, hence these are opposite, hence this is trans. And here you can see that when all the four groups are different, this is alkene, carbon-carbon double bond. When the four groups attached to alkene are different, then we can say it, we can distinguish it as cis and trans, and also we can name it by Z form and E form. Okay, see, in this case we have to give the priority to the groups which are attached to carbon of the alkene. Out of this fluorine, we have to consider this carbon atom. We have to consider this carbon atom. There are fluorine and chlorine are attached to this first carbon atom. We have to give the priority to these two atoms which having the higher atomic number or the higher mass, that is given a higher priority. Out of fluorine and chlorine, chlorine gets a higher priority than fluorine, and out of bromine and iodine, which are attached to same carbon atom, iodine gets the higher priority. So out of this fluorine and chlorine, when you consider this carbon atom or this group, the chlorine gets the higher priority, and when you consider this carbon atom, this gets the iodine gets the higher priority. So iodine and chlorine higher priority groups on the same side of the double bond, hence this is called cis. When the higher priority groups on the same side, then that form is Z form. Here in the second isomer, fluorine and chlorine gets the higher priority group, you can give 1, and iodine gets a higher priority group out of iodine and bromine, and higher priority groups on the opposite side of the double bond, hence this is trans. When it is trans, means higher priority groups on the opposite side of the double bond, then we can name it as E form. Okay, when the higher priority group on the opposite side, then that is E form, and when the higher priority group on the same side of the double bond, that is G form, and also Z form, or you can also call it a G form. Okay. Next is, here also let's consider this carbon atom, bromine and methyl groups, and bromine are attached to this carbon atom. So bromine gets the higher priority than the methyl groups, and OH and carbon, when you consider this carbon atom, OH and hydrogen, OH gets the higher priority because oxygen having higher molecular mass, atomic number. Out of OH and hydrogen, OH gets the higher priority because oxygen is having higher priority, oxygen having higher atomic number. So here you can see bromine and OH are on the opposite side of the double bond. When the higher priority group are on the opposite side, then it is trans, when it considered for cis trans, and when the higher priority groups on the opposite side, it is called as E form. Here also bromine gets higher priority and OH gets higher priority, and both higher priority group on same side. When it is same side, then we have to give the Z form or G form. And these are also known as diastereomers. We shall understand this while discussing about the stereo optical isomers. Next example is, here the CS3, the carbon is attached to this carbon atom, but here we have another CS3 group attached to this carbon atom, hence the priority is 1 to this than the just methyl group, because here out of these two the carbon is same group is attached to this carbon atom, but this carbon is attached to another carbon atom, so that this gets the higher priority than the methyl groups, so that this is higher, CH2 CH3 is the higher prior, and here this carbon is attached to oxygen in both the molecule, both the groups, but this oxygen is attached to hydrogen, but this oxygen is attached to carbon atom, so that this gets the higher priority. And when the higher priority group on the same side, then this is G form. This is higher priority because this carbon is attached to another carbon atom, and here this methoxy group means oxygen attached to CH3 group is higher priority. When this higher priority group on the opposite side, then it is E form. Here also same, the N is nitrogen is attached to CH3, hence this gets the higher priority than this, and bromine gets a higher priority than chlorine because of higher atomic number, hence it is G form. NH, this gets a higher priority, NHCS3, and bromine gets higher priority, hence it is E form. Next, see, both are CH3, but this is 13 isomer, 13 carbon, but it is 12 carbon. This is 12 carbon, here it is 13 carbon. Okay, the mass number is different here, so that this gets the higher priority, and deuterium gets a higher priority than the hydrogen, hence the deuterium gets the higher priority, one here. When both are opposite, it is E form. Here also this gets the higher priority and deuterium gets a higher priority, both are on the same side, hence it is G form. When you consider the oxime, next example oxime, when you consider the oximes, it depends upon the hydrogen atom. When the hydrogen and the OH on the same side, you have to give the name as syn. You have to give the name as syn. And when the hydrogen and the OH on the opposite side, then we have to give as anti. When it is oxime, we have to consider hydrogen of the carbon and nitrogen of the OH. When OH and hydrogen on the same side, that will be syn. Hydrogen and OH are opposite, then that is anti. Here also same, but here there is no hydrogen. Then when there is no hydrogen, we have to name this based on OH. Based on the OH, we have to give the name, means see here, this is ethyl group this is ethyl group, and this is methyl group. This is ethyl group and this is methyl group. Ethyl group is syn to OH. We have to give the name according to OH, with priority OH. This ethyl group is syn to OH, but this methyl is anti to OH. This is anti, correct, this is syn. When you have to give the name, see here, syn ethyl. Ethyl group is syn to OH, hence we have to give the name syn ethyl. We should not write the whether it is one. We have to consider only the ethyl group. When you are writing the ethyl first, then you have to give the name like syn ethyl. There is no need to write anti-methyl. Just you have to write syn ethyl methyl oxime. Or if you want to take this methyl group first, we have to give anti, because methyl group is anti to OH, hence anti-methyl ethyl oxime. There is no need to add syn here. We should not write syn in the place of ethyl. Okay, there is no need to write syn. Just we have to write the anti-methyl ethyl oxime. Here also same, see, methyl group is syn to OH. When you take this methyl group first, it is syn methyl, and there is no need to write ethyl group is at the anti position. When the methyl group is on the syn, obviously ethyl group will be on the anti position, hence syn methyl ethyl oxime. When you want to take this ethyl group first, then that is anti-ethyl, and methyl group will be obviously on the syn position, hence anti-ethyl methyl oxime. Like this we have to give the name in case of oximes which don't have hydrogens. Next example is here the cyclopropane having two methyl groups, both are above the plane, means here you can see the CH3 and CH3 are on the same side, means above the plane, then that is cis. When this CH3 is above but this is below the plane, then this is trans. These are opposite side of the rings, but these methyl groups are on the same side of the ring, and these are called as cis, and this is trans. See, the both are having hydrogens here. This carbon is also having hydrogen, this carbon is also having hydrogen. Hydrogens are on the same side, hence it is cis. But here hydrogen is below the plane and this is above the plane, hence it is trans. Like this we have to distinguish the cis and trans. Okay, thank you for watching this video.